How do we find the distance between 2 points using the distance formula? That's what we'll be going over in today's Wrath of Math lesson. Let's say we've got 2 points. The first point has an x-coordinate of x1 and a y-coordinate of y1, and the second point has an x-coordinate of x2 and a y-coordinate of y2. Then the distance formula tells us that the distance d between these 2 points is equal to this: the square root of, and then under this square root, we've got the difference between the x-coordinates, x1 minus x2 squared, and then to that we add the difference of the y-coordinates squared. So it looks a little ugly, but it's not that bad. We just take the difference of the x-coordinates, x1 minus x2, and square it. Then do the same thing with the y-coordinates, y1 minus y2, square that, then add them together and take the square root. And you don't have to worry about memorizing this formula, because at the end of the lesson we'll go over where it comes from. So if you ever forget the formula, you'll be able to figure it out again on your own. So let's stop dilly-dallying and check out an example. Here we've got a beautiful Cartesian plane. Let's plot 2 points to find the distance between. Let's say we've got the point -1, 2, which is right about there. That's -1, 2. And then we'll also plot the point 4, 4, which is right about there. So how do we find the distance between these 2 points? We're looking for the distance, which is the length of this purple line segment right there. Well, using our handy-dandy distance formula, we know that the distance between these 2 points is equal to this: the square root, and then we've got the difference of the x-coordinates. In this case, that's -1 minus 4. So we've got -1 minus 4, and then remember that is getting squared. Then to this, we add the same thing, but with the y-coordinates. Take the difference of the y-coordinates. In this case, that's 2 minus 4. 2 minus 4, and remember, this is also getting squared. When using the distance formula, be careful to not fall into the trap of canceling out these squares with this square root. Because we've got addition going on in here, we need to evaluate what's under the square root before we apply the square root. So let's go ahead and do that. What do we have under the square root? We've got -1 minus 4 squared. -1 minus 4 is -5, so we've got -5 squared. Then 2 minus 4 squared. 2 minus 4 is -2, so we've got -2 squared. What is -5 squared? -5 times -5 is positive 25, so we'll replace that with positive 25. Then -2 squared, -2 times -2 is positive 4, so we will replace that with positive 4. And what is this equal to? Well, that would be the square root of 29. I prefer to just leave it like that. That is an exact answer. But if you want an approximation, this is approximately 5.39. So the distance from this point to this point is exactly the square root of 29 units, or approximately 5.39 units. One of the nice things about the distance formula is that the order of the x and y coordinates doesn't matter. We can see if we had swapped the order of these x-coordinates, instead of -1 minus 4, we'd have 4 minus -1. 4 minus -1 is 4 plus 1, which is 5. 5 squared is 25. Changing the order of subtraction will just make the difference positive or negative, but since it's getting squared, it's going to always end up positive anyways. So where does the distance formula come from? Well, hopefully you remember the Pythagorean Theorem, and we can use that to solve this problem, finding the distance between these 2 points. And what we'll find is that the Pythagorean Theorem gives us the same equation as the distance formula, so that is where it comes from. If you don't remember the Pythagorean Theorem, it just tells us that in a right triangle, the sum of the squares of the legs, a squared plus b squared, is equal to the square of the hypotenuse, c squared. So how can we apply this theorem to this situation, finding the distance of this line segment? Well, a good place to start would be to introduce a right triangle, because we can't use the theorem without a right triangle. So let's draw a line segment from this point that keeps the same y-coordinate, y equals 2, and goes all the way out to x equals 4. And then we'll do a similar thing with this point. We'll draw a line segment that keeps the x-coordinate of 4 and goes all the way down to y equals 2. These segments intersect in a right angle. At the point with the same y-coordinate as this point, which is 2, and the same x-coordinate as this point, which is 4. And we know they intersect at a right angle because this line segment is parallel to the y-axis, and this line segment is parallel to the x-axis. Since the x and y-axes are perpendicular, these line segments must be as well. So now we've got a right triangle. Let's call this leg A, this leg B, and our hypotenuse C. Now we can use the Pythagorean theorem. For starters, what is the length of A? Since it keeps the same y-coordinate all the way through, the length of this segment is just the change in the x value. It goes from -1 to 4, so the change can be expressed as 4 minus -1. And remember that this needs to be squared. Then what is the length of B? B keeps the same x-coordinate all the way through, so its length is the change in y value. We go from 2 to 4, so that length is 4 minus 2. And remember, this needs to be squared as well. And this is equal to c squared. We want to find c, the distance, so we should take the square root of both sides to get rid of this exponent. Then, taking the square root of c squared leaves us with c, I'll write that here. What is that equal to? It's equal to the square root of all of this junk. And you can see this is exactly the equation we had above using the distance formula. So that's pretty cool. That's where the distance formula comes from. It's just a useful application of the Pythagorean theorem. Now here's an example to try on your own. Using the distance formula, find the distance between the point 1, 1 and 2, 3. And let me go ahead and copy and paste the distance formula above just for your reference. Bring this right on down. So there's the distance formula. Let me know what you get down in the comments. As always, I'll leave the solution in the description. So I hope this video helped you understand how to find the distance between 2 points using the distance formula. Let me know in the comments if you have any questions, need anything clarified, or have any other video requests. Thank you very much for watching. I'll see you next time, and be sure to subscribe for the swankiest math lessons on the internet. And a big thanks to Valo, who, upon my request, kindly gave me permission to use his music in my math lessons. Link to his music in the description.